Base classes. The basic building blocks for any verification environment are the component, drivers, sequencer, monitors, and transactions class objects that contain actual data they use to communicate. From the UVM hierarchy, we can see that most of the classes in UVM are derived from a set of core classes that are described below. The UVM void. This doesn't have any purpose, but serves as a base class for the UVM classes. UVM root. This is an implicit top-level UVM component that is automatically created when the simulation is run, and users can access via global UVM underscore package scope variable UVM underscore top. Please note the following property of UVM underscore top as an instance of UVM root. Any component whose parent is set to null becomes a child of UVM underscore top. UVM underscore top manages the phrasing of for our components, and UVM use UVM top to search the component based on their hierarchy name. For example, find UVM underscore top dot asterisk dot USB underscore drive 0 and use UVM top to globally configure the report verbosity, logs, files, and actions. For example, UVM top set underscore report underscore verbosity underscore level underscore higher. The UVM4 would set a full verbosity for all components. The UVM's reporting mechanism is accessible from anywhere outside the UVM underscore component, such as in modules and sequences. It's worthwhile to note that UVM top checks for errors during end of elaboration phase and issues a UVM fatal error to stop simulation from starting. See class definition to know more. UVM underscore object. The main role of the UVM object is to provide a set of methods for common operations like create, copy, and compare, print, and record. Since all major UVCs and transactions are derived from the UVM underscore object, all these functions are available for their use. See class definition to know more. UVM underscore report underscore object provides an interface to a UVM reporting facility. All messages, warnings, errors issued by component go via the interface. There is an internal instance of UVM underscore report underscore handler, which stores the reporting configuration on the basis of which the handler makes decision on whether the message should be printed or not. Then it passed to a central, the UVM underscore report underscore server, which does the actual formatting and the production of the messages. A report has a ID string, severely, verbosity level, and text message, and may include a file name, file number from which the message came. If the verbosity level is greater than the configured maximum verbosity level, it is ignored. For example, if the maximum verbosity level is set to the UVM medium, and you issue a statement like UVM underscore info status register have been updated, UVM high, then you will not see this message in the output. By setting the UVM high in the message, you are telling the report server that you only want the message to be printed out when you want tons of messages printed out. This is useful for debug purposes, and you can see the message level to UVM high for all debug-related messages, while you keep the maximum verbosity level to the UVM medium. That way you have the ability to switch between output levels. UVM component. All major verification components are derived from the UVM component and already inherit features from the UVM underscore object and the UVM reporters object. It has the following interfaces. Hierarchy. Defined method for searching and traversing the component hierarchy. For example, env0.pci0.master1.drive. Phasing. The defined phase system that our component can follow. For example, build, connect, run, and etc. Reporting. Define an interface to a report handler and all messages, warnings, and errors processed through this interface derived from the UVM underscore report underscore object. Recording. Define a method to record transactions produced consumed by the component to a transaction-based database. Factory. Define an interface to UVM factory used to create a new component object based on an instance type. Note that the UVM component is automatically seeded if the UVM seeding is enabled, but all other objects must be manually reseeded via UVM underscore object reseeded. Next is UVM transaction. This is an extension of the UVM component and includes a timing and recording interface. Note that simple transaction can be derived from UVM transaction, but sequence-enabled transaction must be derived from UVM underscore sequence underscore items. Thank you. This chapter, the UVM utility and field macro. UVM uses the concept of a factory where all objects are registered with it so that it can return an object of the requested type when required. The utility macros help to register each object with the factory. UVM also introduces a bunch of the automation mechanisms for implementing print, copy, and compare objects are defined using the field macro. Utility macros. The util macro is used primarily to register an object or a component with the factory and is required for it to the function correctly. It is required to be used to inside every user-defined class that is derived from the UVM object, which includes all types of sequence items and components. Object utility. All classes derived directly from the UVM object or a UVM transaction require them to be registered using UVM object utils macro. Note that it is mandatory for the new function to be explicitly defined for every class and takes name of the class instances as an argument. Component utility. All classes derived directly or indirectly from UVM component require them to be registered with the factory using UVM underscore utils macro. Note that it is mandatory for the new function to be explicitly defined for every class derived directly or indirectly from UVM underscore component, and takes the name of the class instance and a handle to parent class where the object is instantiated. Macro expansion behind the scenes. The UVM object utility eventually gets expanded into its asterisk begin and asterisk end from nothing with nothing between the begin and end. The asterisk or star begin underscore begin implement other macro required for the correct functionality of UVM factory. It can be seen from code shown below that each macro expanded by star underscore begin implement some functions required for factory operation and perform the following steps. Implemented getType static method which basically return a factory proxy object for the requested type. Implemented create which instantiated an object of the specified type by calling its constructor with no argument. Implement get underscore type underscore name method will return the type as a string. Register the type and with UVM factory. In a similar way, UVM component utils also has a equivalent macros and function calls. Note that the create function to component takes two arguments, name and parent, unlike that of an object. Parameterized classes should use UVM underscore object underscore param underscore utils, since they do not have a give to a type during factory registration. Creation of a class object. It's recommended that all class objects are created by calling the type underscore id colon create method, which is already defined using the macro m underscore uvm underscore object create underscore func. This makes any child class object to be created and returned using factory mechanism and promote test bench flexibility and reusability. The field macros. UVM underscore field underscore star macros that were used between the stars underscore begin and star underscore end utility macros are basically called field macros since they operate on a class properties that provide automatic implementation of core method like copy, compare, and print. This helps the user save some time for implementing custom do copy or do compare and do print functions for each and every class. However, since these macros are extended into general code, it may impact the station performance and are generally not recommended. Usage example. The UVM underscore field underscore star corresponding to the data type of each variable should be used. For example, variables of type int, bit, byte should use UVM field int, while variable type string should use UVM field string, and so on. The macro offset allows two arguments, arg and flag. Arg, name of the variable, whose type should be appropriate for the macro that is used. Flag, when set to something other UVM default or UVM all on, as specified, which data method implementation will not be included. For example, if the flag is to set no copy, everything else to be implemented for variable except copy. The field flag can take the following values and multiple values can be ORed together. A combination of these flags determine the kind of operation that are allowed to be done on the given variable. The UVM all on, all operations that turn on. UVM default enables all operations and equivalent to UVM underscore all underscore on. UVM no copy, do not copy the given variable. UVM no compare, do not compare the given variable. UVM no print, do not print the given variable. UVM no pack, do not pack or unpack the given variable. UVM reference, operate only on handlers, that is, for object types, do not copy, deep copy, and etc. Along with the control on operations, UV_field_star methods also provide some control on the radix of the given variable, which can take the following values. This value can be ordered with the operational flag listed in the table above. UVM hex is the default lattice if none is specified. The UVM being decimal, hex, oct, string, time. Print or record the given variable in binary format, decimal format, hexadecimal format, octal format, string format, and time format. See more examples of field markers in print, copy, and compare and pack. Thank you. This chapter, UVM Object Print. The UVM underscore object as the base class from which all other UVM classes for data and components are derived. So it is logical for this class to have a common set of functions and features that can be availed by all its derived classes. Some of the common functions usually require is the ability to print each content and copy content from one object to another and possibly compare two objects. UVM has many automation macros that get expanded into full code during compilation and implement these functions for all classes with each. Example. The purpose of the example is to show how the UVM automation macros can be used to print variable content easily. A class called object is derived from UVM object, thereby inheriting all functions with the parent class. A few variables of different data types are declared and attempt is made to print the content of these variables after randomization. There are different variations of UVM field star macros for each data type, and the variable have to be registered with the macro corresponding to each data type. The UVM default indicates that the given variable should be used for all the default UVM automation macros implemented by the object, which are copy, print, compare, and record. To test the above code, we will simply use your base test class that will print content of the object. By default, the UVM printer prints content of any object in a table format in which is specified the name of the variable, data type of the variable, its size and value. In the simulation output shown below, it can be seen that the obj was randomized to given rules, given values. It's quite interesting to note that even arrays, both static and queues, are printed with the content of all their indices. Using do print. Using automation macros are not recommended these days because it introduces quite a lot of additional code and reduces simulation performance. Instead, it is recommended to use do star callback hooks to implement the requirement. For example, to print the content, the user can implement the function called doPrint inside the derived object and not use the automation macros at all. DoPrint, a function, is called by the print function by default, and hence whatever is defined in doPrint will be printed out. In this case, we will simply print three selected variables, although you can print all variables as required. This results in a very similar output like the one by UVM underscore object underscore util star. Note that it prints only three variables because only three variables were implemented inside the doPrint function. The using sprint. The UVM object have another function called sprint that returns the formatted content in a sprint format. It is a substitute of the print function, can be used as shown in the example below. Assume the class declaration is the same as the first example shown above without the use of the UVM automation macros. As you can see, it produced the same table format as string but prefixed by custom text called content. Using convert to string, there is another function available in a UVM object called convert to string that will return a string instead of a print the content in a predefined format. This allows you to define the output into a format you like. For example, we can simply print content into a single line as shown. Class object extend the UVM object. In the test class, we will have to call convert to string instead of print or as print. But remember that this function returns a string and hence has to be within a UVM info or similar report macro. Simulation log. Thank you. This chapter, this section, UVM object, copy, and clone. UVM object has many common functions like print, copy, and compare that are available to all its child classes and can be used out of the box if the UVM automation macros are used inside a class definition. In previous article, print to print and the use of automation macros to print were discussed. Using automation macros, a class called packet is defined with a single variable and registers using UVM automation macros between UVM underscore object and the utils begin and the UVM object utils end. A variable used with the UVM default setting means that this variable will be included in our automated method like copy, print, and etc., unless specifically mentioned. An object of a packet is instantiated in another class called object along with a bunch of other variables of different data types. Similar to the packet class and all variables in object are registered with the UVM automation macros with the corresponding macro type. For example, string variable require UVM underscore field underscore string. Type definition type false and true bool this type. Let us create a test class and create a two object of a type object, randomize both and display them first. Then content of obj1 and copy it into obj2 using the copy function. Implementation of this copy function is taken care by automation macro. So the first table shows the values of the obj1 after the randomization. The second table that obj2 that after randomization, and third one shows the content of obj2 after copy method is called. Automation macros introduce a lot of additional code and is not generally recommended. Using do copy. Okay. Another way to Another way is for user to implement doCopy method inside the child class and assign the value from each variable of the class to be copied in the current one. Note that Note in the following example that UVM object utils macros are not used and hence print method we use above will not work as is. Instead, another method called convertString to implement it for both classes so that it returns the content in a string format and when called. Just like the way print calls doPrint method, a copy calls doPrint method, the doCopy method, and implemented a function is all that is required to be done. Type num false true EUVM right here. Okay. Mm. Like an earlier example, two objects are created in content of one is copied into another. Because doPrint method is not implemented and automation macros are not used, convertString will be used to print content of each class. Using clone method. Clone method works exactly the same as a copy method, the difference being that a clone will return an object and the copied content. So this saves some trouble of creating the second object before copy. Thank you. Object compare. The UVM object compare. Object has many common functions like print, copy, and compare that are available to all its child classes can be used out of box with the UVM automation macros are used inside the class definition in previous article. Copy, decopy, and the use of automation macros to be print were discussed. Using automated macros. UVM automation markers can be used for automatic implement of copy, print, and compare, and more. In this example, a class called packet is defined with a variable called m underscore addr that is registered with the automation macro UVM field int to be included for all the default functions like print, copy, compare, and etc. An object of this class is used inside another class object which has a bunch of other variables of different data types that are also registered using appropriate macros. For example, mbool is a enum type and is registered with the UVM field enum macro. And let us create a base class and create two objects, obj1 and obj2, randomize both and print them. Then compare both objects to see what the result is. Then copy each variable from obj2 from obj1, including the nested class object of type packet until the comparison errors are resolved. So, but automation macros introduce a lot of additional code and is now generally recommended. Using do compare. Another way is to for the user and to implement do compare method inside the child class and compare the value of each variable and return the result. Note the following example of the UVM object util star macros are not used to and hence the print method we used above will not work as is. Instead, another method called convertToString is implemented for both classes so that it returns the content in a string format when called. Just like a way print calls doPrint method, a compare called doCompare method An implementation of function is all that is required to be done. The UVM automation macros were used in the previous example, and hence the print method implementation was already done and available to be used. However, when automation is used, user has to implement it there to print and at least field the convert to string function so that the contents can be printed. We have chosen to do the latter as evident as code above, so the convert to string function is called in a UVM info statement instead of calling print. Then to compare the variables, copy each variable obj to obj2, obj1 into obj2, and keep comparing until both objects are same. Thank you. UVM object, pack, and unpack. The UVM automation macros also include mechanisms to pack class variables into a bit or a byte stream and unpack a string, a bit stream, and populate the class content. This is particularly useful when dealing with the serial forms of communication like SPI, I2C, and RS-232. There's three main functions available to pack and unpack. Pack. Perform a bitwise concatenation of the class content into an array of type bit. Pack byte. Perform a bitwise concatenation of class content into an array of type byte. Pack int. Perform a bitwise concatenation of class content into an array of type int. Unpack. Extract property value from an array of type bit and store into correct class variable. Unpack bytes. Extract the property values from an array type byte and store into a correct class variable. Unpack _int. Extract property value from an array of type int and stores into correct class variable. In the following example, usage of all three types of functions will be explored using automation macros. Pack, a class called pack, is defined with some variables to store address and data, and it registers with UVM field int macro to enable automation. UVM default specifies that all default automation methods should be applied to given variable. Note that the order of a variable as listed within the UVM object util underscore will be used for both packing and unpacking data. Let us create a data class called path underscore test where an object of packet is created, randomized, and packed. See the function pack returns an array of bits, pack bytes return an array of bytes, and pack bits return an array of ints. Note that the pack bytes padded 0 to the content from the m underscore wr to turn it from 1 to 8. Unpack. Let us create a different test class called an unpack underscore test will be created to packet object, but randomize only one of them, leaving the other empty, and then pack contents of the first object into an array, and then unpack it into a second object and display its content. Repeat the same thing with other types of pack functions. Remember that the order in which it packed should be as same as the order in which it is unpacked. Any change in packer policy regarding order may cause the result to be different. The automation macros introduce a lot of new code and is not generally recommended to be used. Using do pack and do unpack. Just like print and copy and compare, pack and unpack also has user definable hooks called do pack and do unpack. The same set of the test shown above can be run with this class and it'll yield the same result. Thank you.